Did you know corals could be an important alternative to planting trees in our fight against climate change? Planting trees is an important method to help reduce CO2 and global warming. This is currently one of our most popular lines of defense against climate change. But there's a trouble with trees. Much of the carbon in the tree's structures is released back into the atmosphere when they die. If the trees burn, such as what happened during the wildfires in Australia or the Amazon rainforest, massive amounts of CO2 are re-released back into the air. Additionally, CO2 is re-released naturally due to microbial organic decay after the leaves, branches, or the tree trunks fall to the ground. Geologically, the lifespan of a tree is relatively short. As if that's not enough bad news, many tree farms completely lack the biodiversity that is critical to balanced ecosystems. Many only plant one species, such as eucalyptus farms. So planting trees is only part of the solution. We need other alternatives also. Did you know there are 2 ways that corals can remove CO2 and help solve the climate change problem? Most people are not aware that corals are photosynthetic animals, and surprisingly, they remove CO2 from the atmosphere in 2 different ways. Yes, corals are unique animals in that they are only one of very few organisms on Earth containing a plant in their bodies that supplies the coral with energy. This plant, a photosynthetic single-celled organism called Zooxanthellae, lives symbiotically in the tissues of corals. And like all plants, these Zooxanthellae in the corals consume CO2 during photosynthesis in a one-way reaction that produces oxygen and energy. This is how corals consume CO2 during photosynthesis. As corals remove CO2 from the ocean water, the concentration of CO2 in the atmosphere also decreases since the air and the ocean constantly equalize their gases through simple diffusion. So through the process of photosynthesis, the single-celled plants inside corals convert CO2 into energy. But corals also remove CO2 from the water in a second, even more important way. When building their stony skeletons, corals use and remove some of the CO2 from the surrounding ocean waters to build those skeletons. Because coral skeletons are comprised mostly of calcium and carbonate. And that carbonate comes from CO2. This is how corals make their stony skeletons from CO2. CO2 in saltwater converts naturally to bicarbonate, and corals use this bicarbonate to build their stony skeletons. As this bicarbonate is depleted by the corals, more CO2 in the air enters the water to convert to bicarbonate, and less CO2 is left in the atmosphere. Calcium carbonate, CaCO3, is the building block of coral reefs. Most of the coral reef is made up of thousands of generations of dead corals layered on top of each other with an outer layer of living corals. The physical structure of most coral reefs is comprised mostly of reef-building stony corals containing both the living corals on the surface of the reef and extensive amounts of ancient dead coral rock, aka limestone, underneath the surface of live corals. This process of reef building is a permanent method of carbon sequestering, turning CO2 into limestone. Geologically, the time span of a coral reef and limestone is relatively long. So all of the dead reef base rock still contains CO2 that is tied up. It is only released if or when the reef rocks are degraded naturally by weathering, often millions of years later, if at all. And because coral reefs are the largest living structures on Earth, the amount of limestone they produce is considerable. We need to grow more corals in the oceans to naturally reduce the CO2 in our atmosphere. Growing more corals will help solve the climate change problem in a permanent way. Plus, you are helping to save the coral reefs also, so you get 2-for-1 benefits. You're saving the coral reefs and helping solve the climate change problem. Scientific Coral is leading the way in coral propagation methods. Beginning in 1990, I created a company that focused on finding ways of propagating large numbers of capture-bred corals to avoid the destructive methods of collecting wild corals off of the reefs. At Scientific Coral, we spent over 20 years developing the most efficient, cost-effective methods to grow over 200 species and 92,000 individual stony and soft corals. For 10 years, we were the largest coral farm in the world because of the propagation methods I developed. Compared to today's methods, used by other reef scientists, I estimate our production methods are roughly 800 times more efficient based upon numbers produced per space in terms of cost and man-hours, and hundreds of times less expensive to produce. Most coral scientists only reproduce 1 to 5 species. We did over 200 species successfully, nearly all with a mortality rate of less than 1%. No other reef scientists are producing anywhere near this many species. We need this variety of species to maintain the biodiversity of the reefs for a healthy, balanced ecosystem. A coral reef with only 5 species is no more a reef than a palm oil plantation is the rainforest. We have always been funded only through the sales of our corals to the public and institutions, and my personal savings. We never received any outside funding, though we tried. We may have been a little bit ahead of the curve. We're not directly affiliated with any corporations or universities, although we have worked closely with Georgia Tech, the Pet Warehouse, Golden Ina, Atlanta Aquarium, John G. Shedd Aquarium, and many others in the past. Currently, I have this patent pending for soft coral propagation. Upon receiving funding, my immediate goal would be to get as many corals in the ocean planted as quickly as possible. And the best way to do this is to put together a team to teach my coral propagation techniques to islanders around the world, particularly in the South Pacific Coral Triangle and the Caribbean. I would coordinate these teams to teach islanders how to use this technology to plant their own reefs free of charge. I'm available to travel and live anywhere in the world to make this happen. I believe this to be the quickest way to get the most corals in the ocean as soon as possible. Our teaching will focus on showing islanders how to use their own indigenous corals to repair their reefs damaged by hurricanes, ships, dredging, dynamiting, overfishing, etc., or plant new reefs where none existed before. Reefs could also be grown in cooler, but just warm enough waters farther away from the equator to survive the ocean warming trends. Large numbers of corals could also be shipped from one area to another very efficiently using our methods. We could also plant new genetic variants that are more heat tolerant and currently being researched. I currently live on a small, uncomfortable, forever rocking sailboat in Queensland, Australia, for the purpose of accomplishing these goals. Although at the moment I'm marooned in Atlanta, Georgia, USA because of COVID-19. Let's plant millions of corals now using our efficient methods to help solve the climate change crisis. Obviously, I need funding to make this happen in a big way. We need to get as many corals as possible planted in as short a time as possible. Unlike trees, corals just keep growing and growing, often exponentially in size. The more corals and the bigger they are, the more CO2 will be reduced. Coral reefs, the largest living organisms on the planet, are a critical component in the carbon cycle. Reefs cover less than 2% of the ocean bottom. We need to save the reefs we have and further increase the number of corals in new locations in the ocean to reduce CO2 and help reduce climate change. Let's use these techniques I discovered to efficiently and inexpensively plant millions of new corals around the world.